So we did Stirling's formula.
Oh, yeah, right.
Is that better? Or?
Yeah.
That's pretty much better.
Okay. Stirling's formula, n factorial, James Stirling. Do you want to read that? This is Dr. Beatty's, not mine, so don't think
That's online.
Yeah. So don't think. Did you put this online?
That's online.
I did publish it today.
Oh,
Yeah.
okay. Okay, so this is, alright, so this is online.
Along with the Vermont integration.
Okay.
Nobody
Okay.
I downloaded it.
Okay.
No,
Okay. If x is a quantity that is estimated, then the absolute error, so the estimate is x minus a, and then the relative error is the absolute value of x minus a over absolute max. So we want the relative error to go to 0, and it doesn't. So we started with the trapezoidal approximation for natural log x from 1 to n, and we got that approximation, right?
That you're flipping just a little on the left side. It's not the same on the board in front as it is on the screen. There you go.
Is that all right?
Yeah.
Okay. Oh, you ready? Okay. So this is the trapezoidal thing that we had. So, and that simplifies to, yeah, we have L out of 1 is 0, and then all the other natural logs will pair up to give us the whole one up to L and n over 2.
Let me ask you a question. Does anybody know what the trapezoidal rule is? What's the trapezoidal rule? You guys should know. What's the trapezoidal rule?
Basically, an average is that
The partition ones have to be equal spaced.
they are. It's an average.
Doing left and right. Yeah. But usually, you divide the interval A, B into n pieces, so each piece is B minus A over n. The reason to do that is because then you have an error estimate. The trapezoidal rule is never any further away from the actual interval than B minus A cubed over n squared, that is the number of subintervals, times the absolute value of the maximum, the maximum absolute value of the second derivative. So you can put an error estimate on it may be 1/12.
Yeah, because it's similar to, that's like Simpsons rule has that kind of thing too.
Yeah, they all have error estimates.
Simpsons.
I don't recall
Right.
Simpsons. I'm not recalling the trapezoidal very well.
Yeah.
But suffice it to say that it exists, and you can go find it if you want. And of course, what would be the maximum second derivative of the log curve between 1 and n? Or across the second derivative, where's the concavity the greatest? Right at 1, isn't it? So, and the concavity, the absolute value there would be 1. So that's the maximum concavity. So you get a pretty high estimate of the difference between the trapezoidal estimate and the pre-lineal, but that's okay. So we use the trapezoid thing because it gives us a very elegant way to sum up the log.
Yeah. Definitely. And then if you do the integral of natural log x, like we talked about, x over x minus x, from 1 to n, evaluated is n element minus n plus 1. So, okay, so we call the difference between the trapezoidal estimate and the actual integral sigma. That's sigma, right?
No, it's delta. Delta for Newton, D for Newton.
Okay. I was thinking sigma for sum.
No, that looks like a signal. Signal's
What does signal look like? Doesn't it?
Well, we talk about the signal.
It's like an O with a little hat.
It's a little hat with the blower. I don't. Well, no, I know lowercase liquid is a signal. It's a standard deviation, right? But on computers, they look similar, don't they?
Yeah, I guess in some.
Somebody give me the benefit of the doubt.
Right, well, I agree.
We're just asking.
Yes, Mac, it's an easy mistake. Yes.
Okay, so delta n minus 1, and we use that 1 because we are having trouble with that before. The error comes on there. The negative 1 is there for a technical reason. So we have delta n minus 1 is our, that's the error, which is that minus the actual integral. So after we add and subtract another element n over 2. Right, so if we add on element n over 2, that'll cancel. Hold on. I guess we should have written all this out.
Look, you see where you now over right here.
Yes.
The line above where your finger is, the ln over 2 that's already there.
Yes.
If you add a half,
There it is, yes.
half again, then it makes it a full ln, and then you have the sum of all the logs.
Right, so that
So
becomes.
that's why you do it.
Oh, wow. Yeah, so that becomes element n minus 1, so it's n factorial, and then it'll also cancel this one.
So that's what you introduced that.
Yeah.
Oh, God, yeah, sorry.
You-
I've been driving all day, so I had all this last night.
Now he's going to drive us right.
You get it wrong.
Okay, all right, so then we claim that delta is convergent. So delta n minus delta n plus 1, which I was going to ask you the reason why you did that, and I believe it's for what comes up ahead.
Makes limit one.
So it's a, yeah, so it's like an increase.
So that we can be sure that the limit as that goes to infinity of delta n is greater than 0.
Okay. Yeah, so if you get a sequence of positive numbers.
Yeah, and so in that expression just about ready to disappear off the top of the screen, you have a minus 1 there on either side, so that just goes away.
Yeah. Okay.
Oh, God.
Okay, so we have this, and then now you get to do a little simplification, which is, that's definitely something I can handle. So this is just that that expression. So let's see, what do we do? Ln n plus 1, and that put that together, that's ln n plus 1 factorial, so that goes away.
Yep.
And then the negative n here, which I did the little jagged line for, and that'll cancel. So we'll end up with n plus 1/2 ln n. I shouldn't have separated that out. N plus 1/2, and then minus n plus 1/2 ln n, and then there's the minus 1. Okay, so, oh wait. Yeah, so we have, yeah. Okay. Okay.
Is that what I did?
Yes, yeah, I was making sure everything was coming. Yes, so that's what we got, the minus 1 right there. Okay, so now we detour to
That's the difference between two adjacent deltas, right?
yeah. Okay. Okay. In order to convert log into something we can handle more easily. So we convert the log into a summation. And we use that with Lorentz series for natural log. Which is that? So,
By the way, that's one of those things like sine and cosine. It's good to have on the top of your head. Just remember that.
natural log.
Yeah, natural log of 1 plus x, where x is, well,
That's the factor. That's like
yeah.
one. Okay.
So, well, how does it go? You start out with x, and then it's minus x squared over 2 plus x cubed over 3. So the powers go up, starting with x, and then signs alternate, and you don't divide by factorial, just divide by the exponent of the power. So it's easy to remember that.
Yeah. Okay. Okay. So reversing the sign, we're trying to get ln 1 minus x. Okay. So there's ln 1 plus x and ln of 1 minus x. So now subtracting the second from the first, see, we're trying to get something that looks like this. So you get this minus this, x to the k over k, and then you have this x to the k over k. So if we